Sometimes we need to solve problems involving motion. In that case, we need to use the formula d equals rt. Let's look at an example of an airplane. In this problem, we've got a plane that flies with the wind. It can go 1,600 kilometers in 2 hours. However, when it flies against the wind in the opposite direction, it takes 3 hours to go 1,950 kilometers. What we want to do is find the average velocity of the plane in still air and the average velocity of the wind. So I made a table so we can see the formula and put all this information in to organize it. Now remember, the formula is distance equals rate times time. What we want to do is look at the two circumstances here, with the wind and against the wind. When the plane is flying with the wind, it can travel 1,600 kilometers, so that's our distance. It says in the problem that it takes 2 hours to do so. However, when it's going with the wind, it's got its own speed, which we'll call r, plus the speed of the wind pushing it, r plus w. When it's going against the wind, it's got the speed of the plane minus the wind, since the wind is cutting into its speed. In this case, since it's going against the wind, it takes longer time, in this case 3 hours, to go 1,950 kilometers. So, from this table we can see our two equations by the formula d equals rt. Well, in this case, r, or velocity, times t, the time, equals distance. Let's take a clean sheet of paper and put our two formulas down and solve for r and w by making a system of equations. Here we have the two equations we just derived. Now what we need to do is solve for r and w. The first thing we might want to do is get rid of these constants 2 and 3 that are factors of r and w. So if we divide both sides of the equation by 2, the first equation will become r plus w equals 800. If we divide both sides of the equation by 3, we'll cancel the 3 factor, and 3 dividing into 1950 is 650. So we have r minus w equals 650. Now these systems of equations are much easier to solve. In fact, it's already set to eliminate the w's by the addition principle. If we add down the left, we get 2r, and if we add down the right, we get 1450. So if we divide both sides by 2, we have r. r comes out to be 725. But what are the units? Well, remember the units were in kilometers and in hours. So r as a rate or velocity would be 725 kilometers per hour. This is the rate of our airplane, r. That would be the rate if there wasn't a wind. But the wind, remember, speeds it up and slows it down. When the plane's flying with the wind, it adds the speed w. Since we know r is 725, plugging that in here and subtracting from both sides, we see that w would end up being 75. So, we know that the plane travels at a rate of 725 kilometers per hour, and the wind travels at a rate of 75 kilometers per hour.